Here is a strange new threshold for local AI. A 27 billion parameter model can arrive as a roughly 17 gigabyte compressed file. That is small enough to feel personal, but large enough to be useful. The catch is that a model fitting in memory is not the same thing as a model feeling fast. Qwen 3.827b is a good case study because the promise and the trade-off arrive in the same download. Qwen's official model card describes a 27 billion parameter open-weight model with native image and video understanding, an Apache 2.0 license, and a 262,000 token native context window. The official team's posts make the local pitch even more concrete. 27B on 17 gigabytes of RAM, 1 million context on 1 GPU, and a 206 token per second result on a single ART X5090. Those are useful signals, but they are not one universal benchmark. They describe specific builds, systems, and settings. The context number needs a second look. 262,000 tokens is the model's native window. 1 million is an extension path, not free capacity. Longer context means more memory pressure and more work for the runtime. So the useful question is not, can the model print 1 million? It is, can your hardware, quantization, serving stack, and workload make that window practical? The same pattern appears everywhere in local AI. The headline is a capability boundary. The lived experience is a systems problem. Now separate storage from throughput. Simon Willison tested a Q4KM build that took about 17 gigabytes on disk. He found roughly 15 to 30 tokens per second on local machines. That is usable, but it is not cloud-like. Meanwhile, Qwen's 206 token per second post is a result on a single ART X5090, not a promise for a laptop. File size tells you whether the model can fit. Tokens per second tells you how long you will wait. They're different axes. Why can a model fit and still feel slow? A dense model keeps moving weights through memory for every generated token. When the working set fits, the bottleneck can be memory bandwidth, not just arithmetic. Then add reasoning. Simon found that Qwen's default extra high reasoning mode could spend 21 minutes on one elaborate SVG. Turning reasoning down made the same kind of experiment much quicker, but less careful. Context length, quantization, batch size, runtime, and reasoning effort all change the result. Local is not a speed setting. It is a stack you have to tune. That stack is the real product. A local file gives you a route you can inspect, move, cache, and run without sending every prompt to a hosted endpoint. It can make experiments more reproducible and put the hardware decision in your hands. But local does not automatically mean private. Logs, extensions, network calls, and the application around the model still matter. The practical choice is a triangle: control, speed, and convenience. You can improve all three, but the trade-offs do not disappear. So who should try it? If the model fits on your machine and your workload values control, image input, long documents, or offline experiments, a 17 gigabyte build is genuinely interesting. If you need instant responses, a hosted model may still win. If you need both, use local for sensitive or repeatable work and hosted for bursts, then measure the handoff. The important shift is not that the laptop replaced the cloud. It is that a capable open-weight model can now sit close enough to your workflow to make that choice real. Download size gets you to the desk. Your workload decides whether you stay.